So we have seen that actually we can apply the sweepline algorithm for computation of the Warner diagram. Only difference is we cannot compute the Warner diagram up to the sweepline position, current position of sweepline, but we can compute the Warner diagram up to some extent where Warner diagram no longer depends on the some sites below the sweepline. So locus of all points for which Warner diagram is not depend on the points below the sweepline forms a sequence of parabolas. That is what we call as a beach line, and we maintain this beach line as a sweepline status. Okay, so sweepline may be that somewhere below, but beach line is little above this sweepline position. So up to that point, we can compute the Warner diagram. That's what we have seen, and we also identified the events. One is the site event, where this new site encountered by the sweep line, then we have to insert the parabola corresponding to the new site. And initially, this parabola is a degenerating parabola, is simple vertical line. And when the sweep line moves downwards, this vertical line opens up and forms a small parabola, and both the endpoints of this parabola, which intersecting with this site immediately above or parabola immediately above, traces out the same Warner edge, and which is not connected to the rest of the Warner diagram initially. After some time, it intersects with this rest of this Warner diagram, and where it actually connects to the rest of the Warner diagram. This is the site event. And similarly, site event is where the new parabola coming onto the picture, coming onto this sweep line status, coming onto this beach line. And another event is when this parabola disappears. Okay, so that is what we call a circle event. And what happens is when there are three consecutive parabolas in a sweep line, and when the sweep line moves downwards, the middle parabola becoming smaller and smaller, and finally it becomes a point, and later it becomes a goes out of the beach line, sweep line status. So that happens. That is called a circle event. That happens when the sweep line is tangent to the circle, passing through the three sides, which are the three consecutive sides in the parabola in this beach line. Okay, where this middle parabola actually is vanishing from the sweep line status. So this sweep line is tangent to this circle at bottommost point. This is the circle event. And we also seen that actually there could be some false alarms, false events. Okay, so yeah, before that actually, so whenever new site is added into the sweep line status, or whenever the existing parabola goes out of this sweep line, we will have a three new consecutive parabolas in the sweep line status. So whenever this new three consecutive sequence of parabolas are formed, you have to check whether those three are defining a circle event or not. How we can check? If you take the circumcircle of the three sides corresponding to these parabolas, and the sweep line should intersect with this circle. Yeah, everybody able to follow what I'm speaking?
Yes, sir.
So if this line is intersecting when sweep line is intersecting with the circle, and then later when the sweep line moves downwards, this sweep line becomes a tangent to the circle. Okay, maybe I'll explain this point once again. So in the sweep line, so let's consider, let's take this example itself. Okay, here, yeah, in this case, if you look at actually here, these three parabolas here, defines a circle event or not. If you look at this circle, circumcircle of the three sides corresponding to these three sides, okay, not intersecting with the sweep line. So there cannot be circle event corresponding to these three. Now we can see that from the diagram that, okay, middle parabola is not vanishing. Okay, let's take another example where so parabola is like this corner diagram is like this. Okay, so if sweep line is somewhere here, the parabolas are like this. Okay, so at this juncture, okay, uh, this is a valid circle event corresponding to the three sides. Suppose you call them as PI, PJ, PK. The circle here, okay, passing through these three sides. When the sweep line is at this juncture, okay, when this tangent and the middle parabola vanishes, becoming a smaller and smaller, become a point and vanishes. Okay, this is as of now when the sweep line is here, it is a valid circle event. For some example, now there is a one site here, new site is there. Okay, if it is here, what happens when the sweep line crosses this one? Then this is the degenerating parabola, and this parabola is opens up. Okay, so that means sweep line is moved to this position. So at this juncture, okay, the parabolas corresponding to other sites are something like this. Okay, and the for the middle one, okay, it no longer be a there. Okay, for the middle one, the parabola will be somewhere like this. Okay, and for this one, yeah, maybe something like this. Now, this coordinate vertex is not a valid one. Okay, So if you look at this revised Warner diagram with respect to this fourth one, this is a PL, okay, and you will have a bisector between these two. Like this, and you will have a bisector between PL and PJ, is something like this, and you have anyway this one, and you will have a bisector between PL and PK like this. Okay, so this modified Warner diagram is like this. So this is no longer a valid circle event. This vertex is not part of the Warner diagram because of the new site encountered. So it will not be there. So the circle event, whatever we found earlier, it is a false alarm. So we should not process that one. You understood this point?
Yes, sir.
How to identify these false alarms? See, if you look at this one, because of this parabola corresponding to PL is coming onto the picture, PI, PJ, PK no longer three consecutive parabolas. So there is no circle event corresponding with these three. Only circle event takes place if the three consecutive sites, parabolas, corresponding sites, okay, adjacent in the sweep-length status, then only it takes place. Otherwise, it won't take place. So whenever there is a change in the sweep-length status, we have to see whether the previous three consecutive sequence of parabolas becoming non-consecutive or not. See here, what is happening here? PI, PJ, PK are adjacent here. After inserting the PL, what is the status of the sweep line? You have a PI and we have a PL. Again, PI will be there and PJ, PK. Okay. So the PI, PJ, PK are, as of now, it is still adjacent. Okay. That is there. But when the bisector between this PI and PL, this one, meets with this rest of this Warner diagram, then what happens? You have a PL, PJ, PK. Okay, this part of the parabola corresponding to PI will go away. That middle one actually defines the circle event corresponding to this one. Okay. Okay. So maybe one step backward. So when you have updated this by inserting the PL here, this is what happened. Okay. So new three consecutive pairs are this one. Not a pair, three consecutive tuple. Three tuple. So for these three, we have to find a circle event and keep track of it and insert into event queue. So when the circle event takes place, the PI will go away from the sweep line status, beach line. Okay. Once that happens, so PI, PJ, PK are no longer three consecutive. What new consecutive this thing is? PL, PJ, PK. Okay. So the event corresponding to PI, PJ, PK not taking place, that we will remove. Okay. When this PI is removed from the each line. Okay, so whenever some parabola is removed, suppose if you have parabola, say 1, 2, 3, 4, say 5, or 3 parabolas are there. So how many 3 tuples are there? This is 1 3 tuple, this is 2, and this is 3. Okay, the three tuples are there. All 3 of them may define a 3 circle events possible. Suppose out of these 3, someone will take place before other one. Okay, so some sequence will be there. Assume that actually 2, 3, 4 is taking place first. That means actually circle event corresponding to the 3 is taking place. 3 is going out. When the 3 goes out, what is left over is 1, 2, 4, 5. When this happens, the triplet corresponding to 1, 2, 3 and triplet corresponding to 3, 4, 5, there's no more a valid. So what we have to do is we have to remove the circle event corresponding to these 2 triplets in the event queue if it is not a valid. Or if you're not removing, we have to keep a track of it, okay, so that it will not take place. Okay, so this is what happens. So this is the action when something is gone away from this one. Same thing may happen, some new parabola comes into this sweep line. Okay, the same thing whenever the new parabola comes, existing sequence. Suppose, for example, let's take a 1, 2, 3, 4, 5 are the existing sequence of parabolas in this one. So these 3 defines a one circle event, these 3 defines another circle event, 3, 4, 5 defines another one. Suppose new parabola came in between 2 and 3, for example. Say, let's assume 6 here. When the 6 came, and this is the new triplet, and this is another one, and this is another one. So these 3 are new consecutive parabolas. So we have to find out whether 3 consecutive parabolas defines a circle event or not. Okay, and if it is valid circle event, you put it in event queue. But by inserting this 6 here between 2 and 3, okay, this 1, 2, 3 is no more a valid circle event here. Similarly, 2, 3, 4 is no more a valid circle event because those no more a 3 consecutive this thing. So circle event corresponding to these 2, we have to remove it from the event queue. Okay, that means whenever there is a change in the sweep lane status, we have to see, okay, this change bringing the new 3 triplets, okay, or it destroying the existing 3 triplets. So correspondingly, we have to take appropriate action. Okay, is that clear? Any questions?
Yes, sir.
Hey, what about others? Yeah, this is the what we have to do it. Now, yeah, that's all actually. But only thing is now what are the data structures and how to do all these operations efficiently in logarithmic time. Okay, so for each event we have to do it in logarithmic time. That is only criteria. There are n site events are there. There are odd n Warner vertices are there. So for each vertex we have to take only logarithmic time. So this is the general complexity. Now how to do this one? So let me ask you one question. So all of you are aware of this single show shortest path Dijkstra's algorithm. Yes?
Yes, sir.
Yes, sir.
So any one of you implemented this algorithm? Yes or no?
Yes, sir.
So what data structure used for this? What
Priority
data
queue.
structure? Priority queue. So in the priority queue, when you are relaxing the edges, you have to decrease the weight of a vertex. Yes?
Yes, sir.
So these vertices are in the event queue or a queue priority queue. Suppose you have to reduce the weight of a say node I. I is in the priority queue. How to look at this node I in the priority queue? You understood the question?
Sir, we just insert the node with the new value in the priority queue, and since it's lesser than the existing value, it will be extracted first when you use extract min. So we don't bother to update the one in the back.
So that won't create a problem later.
No, sir. For distras, it doesn't.
Yeah, in this case of digital algorithm, you no need to do this one. Suppose if I don't want to insert a new element for node I want to update this existing node I value. How I can do it?
So maybe you have to use another data structure like balance binary, BST.
No, using this priority queue only. See, in the priority queue, there is an operation called reduce key, which can be done in logarithmic time. Okay. See, in fact, actually, you are partially correct. Okay. The node I in the priority queue, we cannot identify where it is in logarithmic time. It can be anywhere. We don't know even the we don't know what value is there in the key, and location of it we don't know. But if you maintain a one array of nodes, okay, at index I, you put a one cross pointer from this array to the location of this node I in the priority queue. Okay. Suppose if you have an array here of nodes, okay, 1, 2, n nodes. Now you have a priority queue here, and node I is somewhere here or somewhere. Okay, you put a one cross pointer from here to here. Suppose if you have this pointer, and using this pointer, we can go directly to this node, and we can reduce this key value. Once you reduce the key value, then you can rearrange this priority queue so that actually, okay, accordingly you modify it and okay, make it again this priority queue. That you can do it, no? In logarithmic time.
Yes, sir.
The idea here is, so you maintain a cross pointers from this array to this priority queue. Whenever node I changes, accordingly this cross pointer also you update it actually in the array. So this can be done without any extra cost. Yes.
Yes.
Everybody convinced about this one?
Sir, that's just decrementing, no, sir?
Yeah, they're decrementing. Yes. The value of key I is decreased. Identify location I and decrease the key value of this node and rearrange this priority queue so that it remains priority queue. That can be done in logarithmic time.
Yes, sir.
Okay, this is what we have to do it. Yes, everybody convinced about this one? Same thing we have to do it here also. We cannot identify the circle event corresponding to the triplet in the event queue. Okay, it's no way, it's the same thing. Whatever the problem here is, the same problem will be there. These events are there in the event queue. We want to remove it, but we don't know where is it in the queue. So we have to maintain some cross pointers to look at this circle events, false alarm circle events, so that actually whenever we have to delete, we can delete it in logarithmic time. Or delete it and rearrange this priority queue. That can be done logarithmic time. Okay. So this is what is the important point here. So if you are clear about the Dijkstra's algorithm, then this is also will become clear. Okay. Now we'll discuss the data structures required for this implementation of the Warner diagram. Okay. Is it okay? Any questions? Okay, there are no questions are there. Yeah. So what data structures are required? So we require a data structure for Warner diagram. So we use a doubly connected list. So is it okay if we use a doubly connected list? There'll be any problems here?
Sir, the unbounded region.
Yes. Yeah, that is the issue. Not all unbounded region. Here we have edges which are extended one direction infinite. Okay, unbounded edges also there. So what we will do is whatever Warner diagram we have, I took some random this thing. So I assume this is the Warner diagram. Okay. So what you do, you bound this Warner diagram in a rectangular box. And we include all these vertices, corners of the rectangle also. And we compute the Warner die within the rectangular box. So these edges also part of the computed Warner diagram sort of thing. So once we bound this Warner diagram within a rectangular box, then we can use a doubly connected list. So only thing is this bounding box big enough so that all the vertices of this Warner diagram should be there. Once this is there, then fine. Okay. Yeah, this is the way we have to use the doubly connected list. Okay, clear? Any questions? Next is beach line or a sweep line status. So we use a balanced binary search tree. Suppose if you have a this like this, PI, PJ, PK, PL. And corresponding to this is the Warren diagram is something like this. Okay. So last time we discussed same manner. Here also we'll have it. At leaf nodes, we will store this parabolas, not parabola exactly. This sites correspond to these parabolas. And intermediate points here represent, say, intersection between these two parabolas. So basically, we will store this pair here, ordered pair here. Similarly, store here. And here, PJ, PK with this store. So basically, these pairs, internal nodes, basically represent, say, Warner vertex, not Warner edge. Okay, these the basically intersection between this parabola PI PJ is a vertex on a point in a Warner edge. That is actually what is there in the internal node. Okay, so given a sweep line location, okay, by means of the x coordinate, some value of x, no? So we can find out for this x value, what is the Warner point on a Warner edge. Given a x value at the sweep line and this PI PJ, these two sides, we can find out what is the. So once we have the PI PJ, we can find out the bisector. Okay, once you know the bisector, for given x value, the sweep line is here. Okay, sweep line is here. Okay, that point must be equidistant here. So this distance and this distance should be same. So you can find out this point on this line. Okay. Similarly, given x value and the point Pi, we can find out the parabola location. Okay. So we are not storing the parabolas here, or we are not storing this point on the Warner edge here, but we are keeping only that sides here, so that actually whenever you require, you can find out the parabola, or you can find out this one given a x coordinate of the sweep line. Oh, sorry, not x coordinate, y coordinate, na? This is y coordinate. What? Nobody pointed out? Are you listening? Hello?
Yes, sir, listening.
Yeah, it's a y coordinate. Okay, it's the horizontal on parallel to x-axis y coordinate. So we can calculate this parabola at the point on the Warner edge whenever is required. Okay. Now, coming to this third data structure, that is event queue. So we use a priority queue itself to store all the events. Okay, nothing fancy about this one. Only thing is, suppose this parabola, the middle one, or not middle one, okay, middle of the PA, PJ, PK in this one as a circle event. So circle event is corresponding to Pj is somewhere here in the event queue. Circle event corresponding to Pj. So you will have one cross pointer here. Similarly, circle event, if it is there for Pk, for that also you will have one cross pointer. Suppose if this during the sweep process, so Pj is okay, is not adjacent to Pi Pk due to some other new site is coming. So we can always use this pointer to locate here in the event queue and remove it. Okay. So this way we maintain the cross pointers. Okay. And we need another cross pointer also here. This vertex, internal node corresponding to this replace this beach line is this sort of Warner edge. Okay. So Warner edge corresponding to this bisect of Pj, Pi, Pj. So you have a doubly connected edge list. In this one, okay, the record corresponding to bisector between the P, Pj, this edge, you will have one cross pointer to this one. Okay. Yeah, this is the records we required, because see, whenever this edge is modified, the corresponding record in the doubly connected edge needs to be modified. Okay, so that is the reason. So these are the data structures are required, and you can perform all the operations whatever we mentioned using the cross pointers in logarithmic time. Okay, and overall time complexity is n log n. Okay, any questions?
Sir, how will we be managing the event queue, sir?
Event queue is a priority queue.
And the priority will what would be the priority?
See, priority is as per the sweep line, top to bottom, by coordinate. See, the way we are processing the event, top to bottom, no? As per the y coordinate, max to min, y coordinate.
Okay, sir, got it, sir.
Any other question? Okay, so just I want to ask you to find out this one. We know that the relation between the Warner diagram and Taylor triangulation. Yes. Now, these two also has a relation with convex hull. Can you find out this relation between this convex hull and this one? Okay, and obviously what we have said earlier, where is this? the regions which are unbounded regions in the Warner diagram, those sites actually on the vertices of the convex hull. Okay, and that is one relation already we know, but something more is there. So all of you just find out, okay, and we will discuss this once again tomorrow. Okay, and regarding the seminars, any questions are there? Already I assigned the dates also. So all of you must present in your time slot. It is not possible to reschedule anybody's presentation. Okay. So that try to understand that one, because it's a big class, the large number of presentations are there, it becomes a difficult. Okay. And you prepare the slides properly so that your presentation will be good. Okay. I'm going to evaluate this presentation very seriously, because this is the where I can do very honest judgment about your effort. Okay. So certainly your grade is going to depend on this one. Okay. If you do well, your grade will be increased. If you do badly, and your grade will come down. Okay. So take this seriously and do. Okay. Of course, you have to do well in the mid-semester and semester also. Okay. And I'm planning to take a 1 hour mid-semester and the 2 hours end semester. Okay. So I think this time
So
we are
what pattern of the mid-semester?
Mid-semester, it's not objective type. It is a subjective questions only will be there. Okay.
Sir, will it be possible for you to give a few practice questions? Because, yeah.
You look at the textbooks and exercise books, you can solve it. Okay. So there's nothing, actually, there are 2-3 textbooks only there. So you can look at those textbooks and solve problems from there. Okay. So any more questions? Yeah. So next week I'm traveling. This week I'll be here. Next week I'm traveling. I'm not very sure I can take classes or not. I may take all 3 classes. I may not take all 3 classes. Anything is possible. But yeah, I may take few classes, 1 or 2 classes also possible. Anything is possible. But all of you check, you log in at the time and see whether at least I'll leave a message if I won't take a class. Okay. On the okay, Teams. So you prepare for that also next week. Okay. I'm traveling. So if everything is already, I'll take classes. Okay. Yeah. Any questions? Okay. So we'll next class we'll take a new problem. That is what is the point location. Okay. So we'll see you tomorrow. Same time.